Okay, so here are the solutions to last night's homework. For those that were absent, I'm just going to go through the whole entire thing. So you feel free to fast forward and rewind this as we go. Okay, so number 1, cosecant, sine, and cosine. It's multiplication because there's no addition sign or anything next to it. So it's just going to be 1 over sine theta times sine theta times cosine theta. Now sine and cosine we just leave, so we can go ahead and put those over 1. And any top with any bottom can cancel. So my final answer is just cosine of theta. Okay, number 2. Cotangent theta we know is cosine theta over sine theta. And again, multiply by sine of theta, which again we can write as sine theta over 1. And what can we cross off? Any top with any bottom. And left with, again, cosine theta. Okay, example 3. Secant theta, we know, is 1 over cos. Tangent of theta is sine theta over cosine theta. And sine of theta is just sine theta over 1. So again, can we cross off any tops with any bottoms? I can't cross these off, can't cross those off, can't cross off the same bottoms or the same tops. So we just multiply straight across. So it becomes sine squared theta over cosine squared theta. And that is tangent squared. Final answer. Okay, example 3. Tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. And secant theta is 1 over cosine theta. So what can I cancel? Well, this cosine with this cosine cancels to 1. This sine with this sine cancels to 1. So what am I left with on top? Just 1s. And what am I left with on bottom? Just cosine. So this simplifies to secant theta. Okay. Number 5. We know that cosine of theta is just cosine of theta. And we want to divide that by cotangent, which is cosine theta over sine theta. So we're going to keep, change, flip. So we keep the cos, change the division to a multiplication, and flip. Alright, so what can I cancel? Let's see. Cos with cos cancels to 1. All I'm left with is simply sine theta. Okay, same concept for 6. Secant we know is 1 over cos. And we're going to divide that by tangent, which we know is sine theta over cosine theta. So we're going to keep, change, flip. Okay, so keep the 1 over cos, change the division to a multiplication, and flip. So what can I cross off? Cos and cos. So 1 over sine of theta is what I'm left with, which is cosecant theta. Final answer. Alright, let's try example number 7. Okay, cosecant squared theta is the same thing as saying 1 over sine squared theta. Remember, we can square them. And then cotangent is cosine squared over sine squared. And then sine squared is just sine squared, or sine squared over 1. Now, in order to add or subtract fractions, we need a common denominator. And what you notice between these two is that there is a common denominator, but this one, there's not. So we can focus our attention just straight on here instead of making the whole thing a common denominator, and it actually might make our lives a little bit easier. So would you agree that if I were to subtract these two fractions, I would get 1 minus cosine squared theta all over sine squared? Okay, and then the variations of the Pythagorean identities, we know that this piece, 1 minus cosine squared, is simply sine squared. So we're left with sine squared theta over sine squared theta, which is what? 1. So we're going to take 1 and subtract this guy from it. So 1 minus sine squared theta, again by the variations, is cosine squared theta. Final answer. Okay. For number 8, we actually have to double distribute. So if I'm going to take 1 times 1, I'll get 1. 1 times negative cos is negative cosine of theta. Cosine of theta times 1 is positive cos theta. And then positive cos and negative cos, when we multiply them together, we get negative cos squared theta. Well, these two I can cancel because they're like terms, and I'm left with 1 minus cosine squared theta. And that is simply sine squared. It's a variation of a Pythagorean identity. Okay, number 9. Let's simplify the top. We know the top would be sine theta times 1 over sine theta, right? I mean, because cosecant is 1 over sine, so don't these cancel to just 1? So my final answer for the top is 1 over cotangent theta. And 1 over something is the same thing as taking the reciprocal. So the reciprocal of cotangent is tangent. So we know that my final answer is tangent theta, which then can be reduced to sine theta over cosine theta. Okay, number 10. From our Pythagorean identities, we can see that cosine squared plus sine squared, this piece right here, is equal to 1. And then we bring down the tangent squared. And this is another identity, which is secant squared. Okay. For number 11, yes, sine squared plus cosine squared equals 1. But you have to, when you add or subtract, you have to add or subtract in the order in which it's given. So 1 minus sine squared you have to do first, which is cosine squared theta. Then you add that to another cosine squared theta. So how many cosine squared thetas do I have? 2. So we write that as 2 cosine squared thetas. Final answer. Okay, number 12. Before I divide 1 over this stuff, let's simplify it. So tangent squared is sine squared over cosine squared. And cosine squared is just cosine squared. So these can cancel. So my bottom is just sine squared. And my top is 1. So what is 1 over sine squared? Cosecant squared theta. Final answer. Okay, let's move on to the next page. Okay, so for number 13, do you notice how there's a secant theta in this term, and there's a secant theta in this term? That means I could take out a GCF of secant theta. So let's go ahead and divide each piece by secant theta. And we write it on the outside, followed by an open parenthesis. So now, what's secant divided by secant, or anything divided by itself? 1, plus secant and secant here are going to cancel, and I'm just left with tangent squared. So if you know your rules, 1 plus tangent squared is secant squared. So we're taking secant squared and multiplying it by secant. That means I have 3 of them. So secant to the 3rd theta. And that's it. Okay. For number 14, before we subtract, let's figure out what this stuff is. So, cotangent, we know, is cosine theta over sine theta. And we're going to multiply that by cosine of theta over 1. So that simplifies to cosine squared theta over sine theta. And we can go ahead and bring this down, but let's bring it down as 1 over sine theta. And subtract. So now that if we have the same denominators, we just simply subtract the tops. So the tops is just 1 minus cosine squared, and the bottom stays as sine squared. And 1 minus cosine squared is sine squared over sine squared, which is 1. Okay. 15. Knowing your Pythagorean identities will help. 1 plus cotangent squared is cosecant squared. So 1 over cosecant squared theta. And cosecant is the reciprocal of sine, so we can just make this sine squared theta. That's it. Okay, let's try question 16. So question 16 says secant squared minus 1. That's another identity. This secant squared minus 1 is the same thing as saying tangent squared. So we can go ahead and make that tangent squared theta over sine squared theta. Alright, well, we know that tangent squared theta is the same thing as saying sine squared theta over cosine squared theta all over sine squared theta. Let's put sine squared theta over 1, so when we keep change flip, it makes life easier. So keep sine squared theta over cosine squared theta, change the division to a multiplication, and flip. What can we cancel? Sine squared and sine squared, and then we're just left with 1 over cosine squared, which is secant squared theta. Final answer. Okay, now number 17 you can do one of two ways. You can either simplify this in the parentheses first, then multiply it by cosine, or distribute the cosine in. I think personally distributing the cosine in made this problem a little bit easier, so I'm going to do that. So this becomes cosine theta secant theta minus cosine theta, or cosine squared theta, right? So cosine of theta we just leave. Secant of theta is 1 over cos. So these cancel. So I'm just left with 1. And it's really 1 minus cosine squared theta, which is sine squared. Okay, 18. 1 over sine squared minus 1 over tangent squared. Well, we know that tangent squared is the same thing as sine over cosine. So 1 over that would be it flipped. So this would be cosine squared over sine squared, or in other words, cosecant, minus 1 over sine squared. And I knew to do that because I needed a sine squared. And now I have the same denominator, so I keep it. And I subtract the tops, 1 minus cosine squared. Well, isn't 1 minus cosine squared sine squared? So sine squared over sine squared equals 1. Okay, next. Number 19. So sine of theta is just sine of theta. Cos of theta is just cos of theta. So we can go ahead and leave that. So sine of theta plus cos of theta times cotangent of theta, which is simply cosine theta over sine theta. So if I wanted to simplify, I guess, this right side of the equation, technically cosine theta can be put over 1, and we're going to multiply the tops. So the tops would be cosine squared theta over sine of theta. And I want to add that to this one over here, which is sine of theta, but now over 1. So when we add fractions, are these denominators the same? No. How do we make them the same? Well, this side has a sine theta, and this side does not. So let's multiply this 1 by the sine theta. So let's go ahead and do that. So the bottom gets a sine theta, and the top gets a sine theta. So what's sine theta times sine theta? Sine squared theta over sine of theta plus cosine squared theta over sine of theta. So now are the denominators the same? Yes. So we leave them the same, and we add the tops. But what's sine squared plus cosine squared? You should be saying 1 from the identities. So your final answer is cosecant theta. Okay, next, number 20. There was a correction on this problem, and this problem needed to have a plus sign in the middle of the two of them. So let's go ahead and change that to a plus sign. And we can do 20 just like we did the other one. We can distribute the cotangent out. So we can make this cotangent theta times tangent theta plus cotangent squared theta. Well, we know that cotangent and tangent are reciprocals, so when you multiply them, you'll get 1. But let's prove it. So cotangent is cosine over sine, and tangent is sine over cosine. And you're multiplying them together. So I can Cross off any top with any bottom. The sines will cancel, and the cosines will cancel. So it all cancels to 1. So 1 plus cotangent squared, if you remember from your identities, are simply cosecant squared theta. Final answer. Okay, so let's talk about question 21. 21 is a little tricky because we don't have a common denominator. So maybe we can make one and see where we go from there. So let's see. This needs a sine theta. Whatever I drew to the bottom, I have to do to the top. This needs a cos theta. Again, whatever I do to the bottom, do to the top. So we've got, make a big line. Okay, so what goes on the bottom? Cos theta over sine theta. Oh, I'm sorry. Cosine theta times sine theta goes on the bottom. And on the top, we've got cosine theta, secant theta, minus sine squared theta. Okay, so we know that cosine times secant is going to be 1. So if you need to know that, you need to prove it to yourself, you can, but they're reciprocal. So anytime you multiply a reciprocal in itself, you get 1. So this part is going to be 1. So it's 1 minus sine squared all over cosine theta, sine theta. And the top, 1 minus sine squared, will give us cosine squared. All over cos theta, sine theta. Okay, so I can cross off one of these coses on top with one whole cos on bottom. So the final answer is cosine over sine, which is cotangent theta. Final answer. Any questions you have on these, I'll be happy to go over them tomorrow in class. Bye.